Okay, so this is going to be part 2 of lesson 2. We started long division. We're going to be finishing off long division and talking about something called the division algorithm. To review long division, let's look at class example number 4 on page 297. So it says consider the polynomial function. It gives us the polynomial function, but it is not in descending order of x. I need you to do two things. I need you to rewrite it in descending order of x, and I need you to make sure that you have zeros as placeholders. So do those two things. So remember, whenever we divide, there's actually going to be two methods of division. Long division is the first. Always descending order of x, and you always need your placeholders. So p of x is equal to, this is a fourth degree polynomial leading coefficient of 6. So 6x to the 4 plus 5x to the 3. There's no x squared, so my 0x squared is the placeholder, minus 4x, and my constant is 1. Remember that the constant is your y-intercept of the graph. We're going to divide the polynomial by this binomial. So remember that that's called a binomial. And the binomial is the divisor. So set up your division bar, and your polynomial function always goes underneath the division bar. The divisor goes in front of the division bar. Okay, so to figure out the first term of the quotient, how we did that is you take the first term of the polynomial and you divide it by the first term of the divisor. So I always do that off to the side. 6x to the 4 divided by 2x. That would be 3x to the 3. Where I'm going to place that is above in my polynomial function, the term with the x cubed. So 3x to the 3 would go here. Then you carry out your multiplication. So 3x cubed times 2x is 6x to the 4. 3x cubed minus 1 is negative 3x cubed. With long division, you always carry out a subtraction. And remember that these first terms will eliminate. So it's going to be 5 minus negative 3. Two negatives will give you a positive. So 5 plus 3x squared, or sorry, x cubed is 8x cubed. And you bring down this term, which is 0x squared. Okay, we need to figure out the second term of the quotient. So again, it's going to be that 8x cubed, always divided by the first term of your divisor. That will give you 4x squared. Make sure that goes above your x squared term. Carry out your multiplication. So 4x squared times 2x is 8x cubed. And 4x squared times negative 1 is negative 4x squared. From here, you subtract. 8 minus 8 cancels. 0 minus negative 4 gives you 4x squared. Bring down your next term, which is a minus 4x, and then repeat. First term, or sorry, this term, 4x squared, divided by first term of your divisor, 2x, and then multiply. So it's very repetitive, same thing over and over again. 2x times 2x is 4x squared, and 2x times negative 1 is negative 2x. This is going to give you negative 4x squared, or sorry, negative 4x, and then we're going to have an addition here. That's going to give you negative 2x's. Bring down your last term, which is the plus 1. Take that negative 2x, divide it by first term of divisor, which gives you negative 1. So that's going to be the constant of your quotient. Negative 1 times the divisor, is going to be negative 2x plus 1. And then when I subtract here, I am going to get two negatives make a positive there, and one, it was originally 1 minus 1 is 0. So remember, I want you to box in this. That is always your remainder. This is my quotient, so we call that Q of x. And then we're going to write the division statement, even though it doesn't ask to write the division statement, and we're going to still do 2c, but let's write what the division statement would be. So I'll just get rid of this. So the division statement is, how could you use the divisor, the quotient, and the remainder to get the original polynomial function? So I'm not going to bother writing this polynomial function. I'm just going to call it P of x. And remember that in order to get that polynomial function, it is dq plus r. So my divisor was 2x minus 1. So right there's my divisor. My quotient was this, and that would be 3x cubed plus 4x squared plus 2x minus 1. And then my remainder would be plus 0. Okay. With long division and synthetic division, which is going to be lesson 3, this remainder is going to be critical. And it's going to be one of two things. The remainder is either going to be 0 or it's not going to be 0. If the remainder is 0, then there's something called the division algorithm, okay? And if the remainder is 0, here's what happens. If your remainder is 0, then your divisor, which was d of x, is a factor of the polynomial. And I'll show you in a minute what that means, is a factor of p of x. If your remainder is any number other than 0, so any other number, then your divisor is not a factor. Of the original polynomial. Why do we care if they're factors or not? Factors give us x-intercepts on our graph, because eventually we're going to be graphing these, and you have to be able to graph these by hand. So because I got a remainder of 0 here, what that means is it says, is 2x minus 1, that was the divisor, a factor of this? Explain. The answer is yes. This is a factor. So it is a factor of p of x. How I know it's going to be a factor of p of x is the remainder is equal to 0. What we're eventually going to do when we find all our factors is you are going to set your factors equal to 0. Once you set your factor equal to 0, you're going to solve. So add 1 to both sides and divide by 2. You're going to have an x-intercept on this graph at 1/2. So this polynomial function is going to cut the x-axis at 1/2 because it's a factor. If this wasn't a factor, if I got a remainder any other than 0, it would not be a factor. There'd be no x-intercept there. Let's look at the last question. Class example number 5. Consider the long division shown. State the divisor, quotient, and remainder. So see if you could just look at this long division, write the divisor, the quotient, and the remainder. Emily, what's the divisor? 2x minus 3. Jaden C, what's the quotient? Jace, remainder? -2. Use the division algorithm to determine p of x. Okay, so here's how we would do this. Write your long division statement using dq plus r, right? So based on this, even though we don't know what this polynomial is, we could figure it out, but it's going to be dq plus r. So here's my divisor. Here's my quotient. And my remainder is -2. I have a remainder of -2. Is this a factor? It is not. 2x minus 3 is not a factor of p of x. So it's just we need to know if they're factors or if they are not factors. I'm going to give you 3 questions to practice. I want you to practice question 4, 9, and 10. So these are just your last 3 questions where you're going to practice long division. So we'll quickly look at the questions, make sure you're able to set them up. I'll give you enough time to do one of them, and then we'll go on to lesson 3. Okay, so explain how to determine if this is a factor of this polynomial. It has to do with the remainder. You say if the remainder is, so I can start it out. If the remainder is 0, then. If the remainder is not equal to 0, then, right? So if the remainder, once we carry out the division, is 0, then x plus 5 is a factor. And if this is a factor, and I set that equal to 0, I will have an x-intercept at -5 if it's a factor. If it's not a factor, then there's no x-intercept there. Okay, so set up your long division for this. You need this is your polynomial function, so that's your p of x. You need to set up zeros as placeholders. There's 2 of them. So write it in descending order of x and put your zeros as placeholders in. X cubed plus 0x squared plus 0x plus 125. And then try 9 and 10.